Today's lesson is just to make sure that you understood 1.1 domain and range, maxima and minima. So I passed out a worksheet in class and I went over the first three questions. We did the first two completely together. And then when we get to the third question, I'm going to ask you to pause the video if you were not with us and try it on your own. And then we talked about it in class and we finished the last two examples. So continuous functions are functions that have no restrictions throughout their domain or on a given interval. Their graphs will not contain any asymptotes or signs of discontinuities. Ooh, that was tough. So basically what's going to happen is you are going to see a graph and you're going to see it either continue forever. So you're going to see an arrow. If you look at question number 2, I do believe you see that. Yes. Here in question number 1, you see it start and you see it stop. You see two ending points. But notice that between the start and the stop in this first one, there's no gaps. It's just continuing from point to point. This is considered continuous. If I were to add another piece, say here, and then it goes like that, this would be considered discontinuous because there's this gap right in here between these two values on x, okay? It might be better to see it right here. So take a look at the second one here. Notice my graph starts here and it goes forever in this direction. This is considered continuous because it's the only graph you see. But if I were to add something like this, now it would be considered discontinuous because I have this gap in between the 2 points. Okay. If I were to bring it over like this, now it is not because there's really no gap here. Okay. That's just the difference. Everything that you're going to see today is going to be continuous, and we're not going to have to deal with that discontinuality. All right, so let's go ahead and talk about the domain and the range. Remember that your domain are your x values. These are your x values. So we simply have to find the x-axis down here, and I'm going to highlight it in blue. And I just have to kind of basically think about squishing this graph to the x-axis. So I want to know, where does it start and where does it stop? Is it continuing on forever towards negative infinity, towards positive infinity, and all that kind of stuff? Remember, when I read my domain, I read from the left and I head over to the right end of my graph. On the left side, I always would see negative infinity. So if there's any kind of arrow pointing off in the left to the left side of your graph, that's going to go to negative infinity. And as I read over to my right, if there's an arrow over here heading off to the right side, either up or down or just straight on to the right, it is going towards positive infinity. All right, so as I read my graph, the first point I see is this point right here at -4. I'm going to write it a little bit bigger underneath. Then I can see that my graph goes up, it peaks, and it comes back down, and it stops right here at 5. Now I also can see that at -4, my circle is closed, and I can see very easily at +5 that my circle is open. Okay. If you see an open circle, you are definitely going to see it. So I do want to draw your attention right here. It does appear that there's a gap in my graph, but I think that gap is really just there to show you the number 5 on the y-axis. It is not there to show any discontinuality. So there's really no stopping to my graph. This is a continuous graph from -4 to +5. To write that in interval notation, I would put the number that I see first on the left, which is -4, comma, and then I'd read until I get to the stopping point on the right, which is +5. If my circle is closed like it is at -4, I would place a bracket. And if the circle is open like it is at +5, I would place a parenthesis. And that's it for interval notation. For set builder notation, I need to start with my squiggly bracket, the variable x, and a vertical line. This is read all the values of x such that, and now I need to write an inequality. Whenever my interval notation is from a number to a number, I'm going to write a compound inequality. So I'm going to start with that -4, which is also the point to the left. I'm going to put a less than or equal to sign because I put a bracket with the -4. Then I'm going to place my variable x, and I'm going to put a less than symbol after it. I'm going to keep it less than because the 5 has a parenthesis. I'm going to finish with the number 5 because that is the open circle that I see to the right side of my graph. And I'm going to go ahead and finish that with a squiggle bracket. And that's it for set builder notation. Okay, a little bit easier if you do your interval notation first. A little bit harder if you do it from the graph. All right, let's go ahead and talk about the range. Remember that the range are your y values. The range are your y values. Now you need to be a little bit carefuler. You need to be a little bit more careful when you read your y-axis. Notice the y-axis goes up and down. It does not go left and right. So I cannot read it from the left to the right because it doesn't go left to right, it goes up and down. So I need to read it, and we needed to all decide, and we decided from bottom, which is where my negative infinity is, up to the top, which is where my positive infinity is. Okay, so we always read our y-axis from the bottom to the top. That looks a little messy. I think I can fix that. There we go. We want to read it from the bottom up to the top. So if I look at my y-axis, the first points I see are these two right here. They would get pulled over and they would get placed right here. Now, I have the open one from 5, but the 4 is going to come in and fill it in. That number is 0. So 0 is the first one I'm going to have. And then it's going to go up till right about here, which I think would be at 5. It's going to go right up here to 5. So it's going to go in between those two numbers. Now notice it's going to be closed and it's going to be closed, and it's just going to fill in between. There it is. I'm going to go ahead and write that in interval notation. So I start with the bottom number, which would be 0. It is closed, so I'm going to put a bracket, comma, 5, and it is closed, so I'm going to put a bracket. Remember, if it's open, you will see it just like you do where x equals 5. You will see that open one. To write this in Set Builder, I'm going to use the same start that I used last time. I just need to change my variable from the letter x to the letter y because we're talking about range. But notice I started with the squiggle. I still used the vertical line, but I just changed my letter from x to y because I'm going from domain, and now I need to talk about range. I have a 0 and a 5 in my interval notation, so I'm going to do my compound inequality again. I'm going to do 0 first because it's the left, less than or equal to because the 0 has a bracket in front of it. I'm going to use the variable y because we're talking about range. I'm going to use a less than and the 5. The 5 has a bracket as well, so I'm going to put that or equal to with my less than, and I'm going to finish with my squiggle. Okay, why did I put the bars underneath my less than? Simply because I used the bracket. I would leave the bar off, I would leave the or equal to bar off if I had a parenthesis. Now, the last part on this worksheet is a little bit new, and it's kind of getting into the next lesson, 1.2, for Wednesday, but it's a good idea to check it right now. We can go ahead and do it right now, and then it'll be easier when we talk about it on Wednesday. This is function notation, and when I am in function notation, this number right here is x. So basically what they're saying here is they're saying x equals -4, and I'm asking for what's y. So in this next one, x equals 0, what's y? X equals +5, what's y? So we are going to find these values from the graph. So let's go back to this first one. Let's find x equals -4. Well, it's right there. What is the y value? We'll just pull it on over here, 0. That's our answer. Let's try that again. X is 0. X is 0. Find the graph. Well, the graph would be up here at, I kind of covered it up, 5. So 5 would be my answer. And for the last one, X is 5. Find it. X is 5. But the graph, look, it has that circle. So is it 0? No, because when I pull it over, it's going to still be open. I would call this one undefined. Can I squeeze it in there? Perfect. Because there's really nothing there. Remember, we're going to practice this one more time if that was a little fast for you. Okay, so let's take a look at graph number 2. Same questions. Let's start with our domain. Remember, your domain are your x values, and you're simply going to go ahead and you're going to talk about the x-axis. Remember, we read it from the left side over to the right side. On the left side, we have negative infinity, and on the right side, we have positive infinity. So these are always things that I mark my graph with to start. Or if you're really, really good, and I tell you what, I mark it every time myself. You need to just make sure that you go through this text checklist and you know which way to read it, and you know where the negative infinity is, and you know where the positive infinity is. Now, the first number I see is that open circle right there at x equals 0. So I'm going to go ahead and put 0 on first, because that is the first one that really catches my eye. Then what I notice is that the graph heads off here towards the left, but does it ever stop? No, the arrow says it's never stopping. So the other point I see is this one right here. Is it going to stop? No, negative infinity. That's what I'm going to use. So the only 2 points I have are 0 and negative infinity. Let's go ahead and do interval notation. If I read from the left, I would have negative infinity, comma, 0. Now I know from my notes that infinity, whether it's positive or negative, always gets a parentheses, and I know that the 0 gets a parentheses because it is an open circle. For set builder notation, all the values of x such that, now since there is only one number, 0, and there's an infinity that's showing up, this is going to be the variable x, and then I'm going to leave my symbol for less than or greater than, and I'm going to put the number that I see. Now, all I have to decide is negative infinity smaller than 0 or bigger than 0? Now, negative infinity might be a little bit of a hard concept to think about, so just really pick a negative number. Negative infinity means just pick a negative number. Is negative 10 bigger or smaller than 0? Well, if you think about it in terms of money, having $0 is better than having to owe someone $10, right? So negative 10 is going to be smaller than 0. So I'm going to say less than. Am I going to say equal to? No, because if I look at the 0, it has a parenthesis, which means it's open, or I can come back and look at it in the picture and it is open right there. So I'm going to leave it as just less than, and I'm going to close up my bracket. Oh no, let's see if we can finish before my battery dies. Let's go ahead and do the range. Remember that the range are your y values, and for your range, you are reading your graph from the bottom, which is where your positive, sorry, no, that's not right, where your negative infinity is, and you're reading it up to the top, which is where your positive infinity is. There, that's correct. All right, as I read up from the bottom on the green bar, the first number I see is 0. The first number I see is 0. So I'm going to go ahead and put 0, comma. And then once again, is the graph ever stopping? So there's the 0. Is the graph ever stopping? No. So I'm going to go to positive infinity. Maybe I could add it like this, right? Same thing here, I had negative infinity. All right, so to positive infinity. I know that infinity always gets a parenthesis because it did last time, and 0 is open just like it was last time, so it's going to get a parenthesis as well. I'm going to go ahead and start with my squiggle. I'm going to change my letter from X to Y because I'm talking about range this time, so my variable needs to reflect that. And I'm going to put the line, so all my values of Y such that, same thing. There's only the number 0. There's only the number 0, and then I see an infinity. So I'm going to put Y, leave a space, 0, close it off. You've just got to decide, is positive infinity bigger than 0 or is positive infinity smaller than 0? Pick a number. Is 10 bigger than 0 or smaller than 0? Well, having $10 is better than having $0. So yes, it is bigger. I'm going to go ahead and say greater than. I could do that better. There we go. And to decide if I'm going to put or equal to, I'm going to go look at the point at 0. It is open, so I'm not going to put the bar. Remember, this says x equals -4. So find -4. There it is. And then go to the graph. There's my answer, +2. This one says x equals -1, so I'm going to find -1. I'm going to go to the graph. There we go. And I'm going to come over here, +1. It's just that easy. This is x equals 2, so find 2. Go to the graph. Is there a graph? There's no graph. There's no graph. Undefined. Ooh, squeezed it in. I do encourage you to pause the video and try this third one on your own, and then you can come back and you can check your answers. So here we go. Now this graph is a little bit different, but same idea. I'm going to read from the left side over to the right side, always from negative infinity to positive infinity. The first number I see is the open circle here at -6. And the last one I see is this point right here, this closed circle. And I have to come down, it is at 7. So it is the closed circle at 7. So basically what's happening is you can take this graph and you can go like this, and it's going to go right in between there and it's going to lay down flat. So in interval notation, I would have -6, comma, 7. My 6 is open, so parentheses. My 7 is closed, so bracket. I'm looking right here and right here. That's how I got those answers. So this gave me that. This gave me this. Okay? For set builder notation, I'm going to do squiggle bracket X such that, so squiggle bracket X line, all the values of X such that, and since I have a number and a number, I'm going to make a compound inequality. Oops, there we go. -6 less than the variable X less than 7, close it up. And you do have to go back and you do have to look at the 6 and the 7. You can look in two places. You can look right here. It's open, so you're not going to put a bar on this less than. And then here at 7, it's closed, so you do need to add the bar to the 7. So that's one way you can decide. The other way you can decide is it's open, so it's less than. It's closed, so it's less than or equal to. So you can look at either one. All right, let's check our Y value. For our range, remember our range is always the tricky one because you do have to read the y-axis from the bottom, which is where negative infinity is, up to the top, which is where positive infinity lives. The first point I see is this open circle right here, and so I'm going to pull it over. The first one I see is my open circle at -4. Then the last one I see as I move up would be this point right here, and I'm going to bring it over and close it in on 8. Okay, what my graph is going to do is it's going to go in between these two numbers, and you could do this if you want. That's fine. So from the bottom, -4, comma, to the top, 8. The 4 is open, so parentheses. The 8 is closed, so bracket, right? And I'm getting that, remember, from this point that I squeezed over and this point that I squeezed over. That's all I'm getting it from. Set builder notation, let's start with the notation. So all the values of y such that, and remember, just like with the domain, I see two numbers, so I'm going to make that compound inequality. Less than y. Don't forget you're changing it to the variable y this time because we're talking about range. Go back and check. Remember, you can check right here. It's going to stay less than because that circle is open. And then 8 is going to be closed, is going to be less than because that circle is closed. So let's add that bar. Oops, I can make that better. There we go. All right, remember that this is x equals -5, so we're going to go find -5. There it is. And we're going to find the graph. There's the graph. And my answer is -2. Okay, this one says x equals 1, so let's find 1 on x. Find the graph, it's up here. My answer is 4, the y value 4. Last one, x equals 6, so find 6 on the x-axis. Go up to find the graph over there. That looks like 7 because it's in between 6 and 8, and that's it. Good luck on the last two questions. If you have any problems, please come in and see me after school. I'll be here till 4:30. Good luck.